Hello everybody, I want to go over the individual training program assignment. So the individual training program, or the ITP, is an applied culminating experience that allows students to demonstrate their knowledge and application of course content related to cardiorespiratory exercise prescription. The assignment is due by 3 p.m. on Tuesday, August 6th. No late assignments will be accepted. You will submit your ITP as a PDF in the assignment area of OAKS. So the individual training program is going to have 4 parts. They're not very long, but I wanted to divide them up here so it would be really easy for you to understand and follow. Part 1, you're going to be working with percent VO2 max. Part 2, you're going to be working with maximal heart rate. Part 3, you're going to be working with heart rate reserve. Part 4 is an area where you're going to show me calculations. So I'm going to give you an overview real quick and then I'll go into details. But whenever you're working with VO2 max, how do you get your VO2 max? Well, you did it during lab. You did a field test. So you either did the 1 mile walk or you did the 1.5 mile run. You could also use your bench step test. If you looked at the book and decided you wanted to do a treadmill test, you could use that value. So there are multiple ways to determine this VO2 max. How about your maximal heart rate? You could do a graded exercise test to determine max heart rate. Also, you can calculate it using the Tanaka et al. And that's probably the way that most of you will be doing it unless you've actually measured it. We don't use 220 minus your age anymore. We use Tanaka et al., which is 208 minus your age times 0.7. Part 3 is working with heart rate reserve. Heart rate reserve factors your resting heart rate into the calculations. And so I'll show you specific examples of that. When you're doing your calculations, be sure that you're using proper nomenclature. So for VO2 max, you're going to make a table, or you can do more than one table, but you're going to show your name. And I'll show you examples of this. You can have your name, age, sex, body mass in kilograms, your VO2 max in METs and in mils per kg per minute. You're going to provide what norm, and I've given you some norms on the end of this PowerPoint. There's specific norms. If you can't find norms in your book or in the ACSM book, you may use the ones that I've provided in the back as examples. The method used to determine your VO2 max, and then your program goal. There are only 3 goals. A, health-related fitness. B, physical fitness, specifically cardiorespiratory fitness. Or C, performance-related increases in VO2 max. Those are your 3. There are no other ones. So use one of those 3. And then your goal category is health, fitness, or performance. Okay. And then the percent range. The percent range is going to match with the method that you use. So there's recommended ranges for percent VO2 max. I deliver those in my lecture. They're also in the book. According to your goal, what's your percent range that you're going to go for? Then you're going to provide a 1-week prescription based on the percent VO2 max, your present fitness level, and the program goal. Provide at least 2 unique modalities with MET values, so you can use the physical activity compendium to find those, and provide relevant details. The relevant details, I need to know what the intensity is so that I can see that you've done the MET value correct. Then provide total MET minutes. MET minutes equals METs times minutes for the week. Here's an example. This nice clean table actually took a lot of work. So we have the days of the week, Sunday through Saturday, the modality. So this student's going to bike, walk, and then there's a rest day. They're going to bike, walk again, and then rest. The intensity for the bike is 9.4 miles an hour. So if I can look, I can see that at 9.4 miles an hour on the bike, that has a MET value of 5.8. I can use the physical activity compendium to figure that out. If they're walking at 5 miles an hour on a relatively flat space, I can look and find that MET value. Okay, so this is what they're going to do. This is the intensity. This is their heart rate response. And so you can actually measure those. So you can bike at 9.4 miles an hour and measure those, or you can graph those and extrapolate those heart rates, or you can calculate them based on percent of VO2 max and percent heart rate. There's an example and an equation of that in the book, and I may show you an example of that on this example. The MET values, use the physical activity compendium is one way to figure those out. Total number of minutes, that's what you determine. MET minutes is METs times minutes equal MET minutes. Total MET minutes, you add up all of your MET minutes here. The recommendation is 500 to 1,000 MET minutes per week. I want to make sure that your total equals MET minutes. So that's part one. Pretty simple. Part two, you're going to determine your heart rate max using your age and Tanaka et al. You're going to graph your heart rate and work rate in METs at two submaximal levels. If you actually perform an exercise, make sure you don't do it above your 85% age predicted heart rate max. Another way to do this is if you haven't done like a treadmill or a bike or gone out and walked at different speeds, but you could do that. You could get on a treadmill and with a certain speed and incline, go for 3 minutes and figure out your heart rate, and then increase the intensity by increasing the speed or increasing the incline, and then do it for 3 minutes and record your heart rate. As long as you have 2 points above 110, you should be able to graph your heart rate response. Okay, so that's one way to do it. Another way to do it is to use Tanaka et al. And then graph your age predicted and VO2 max. You can use this